Well, this is the final presentation of robotics. Here's Renato, Erika, and myself, Miguel. Well, first we wanted to do a Gantry robot. We saw the Gantries right in the mechatronics lab, and we liked them very much, and we decided to try to make one ourselves. Unfortunately, because of several time, we couldn't implement the C axis, so we just have an XY robot, which is perfect for the time we had. What were the building blocks? Well, we needed the structure first. We needed like where we have the X and Y axis. We needed H bridges for enable for the motors to move by directional, and Arduino so that we can control it. We added joystick so we can control manually. And well, we added the pen so we could write. Basically, the three levels we had minimum, target, and wow factors. Where as the minimum, we wanted it to write some letters, be able to do something automatic without us interfering. The target, we wanted it for grid, sort of like a chess game, where the user selects the grid and it moves in that grid. And the wow would be like the user could control a mouse with the computer, and the robot will move. Unfortunately, we tried. The problem with the target and the wow is that they needed PIDs. We designed the PIDs, but the Arduino wasn't able to compute them all simultaneously. We needed 2 PIDs for velocity and 2 for position, each one for each axis. Unfortunately, but because we needed to move in X and Y at the same time, the Arduino was messing it up everything, and we weren't able to compute. So basically, our target and wall we weren't able to achieve in this long time.
At this moment. Excellent. Okay. That's fine.
Well, here was like a demo of the application. Well, it first draws like the hello in the XY form, and the last figure was trying to do a circle using the parametric equation. Unfortunately, because we don't have the PIDs, we cannot make it a very smooth circle, so that's why it moves
all crooked.
Well, the biggest challenge for me, I could say that it was constructing the structure, because we've never like done something like that. We've done cars and everything, but to build a car is relatively easy. Here you have to build a structure that has something in it that moves, and that to me was like very difficult.
You have to adjust to what materials we had. We had to adjust in this metal
rail or guide?
Yeah, guide.
Okay.
Because that was the measurement that we found, so we have to adjust everything to that. I don't know, like you said, like to put the motor so they could stay put and don't like fall off. It was like a really big challenge.
Well, for me also, like the mechanical part, I guess it was the hardest part. Like to put the motors and everything at the beginning, it looked like pretty good, but then it started working and some problems started to show up and everything. So I guess the mechanical part in this project was very important. So as they said, like when everything started moving.
Because that's not like our area of like mechanical stuff. It's more like programming and something like that, to build something just out.
Well, we have like they're not like real parts. Like as you can see, like it's not chain like like plastic. So you have to adjust everything so that it can like move and work, and so the force is okay and everything is good. So it's actually like mechanical for it.
Okay.
What did you learn? Well, basically what I learned is what it takes to build a gantry, a real gantry. What real engineers face outside. Basically the same problem we came here. Obviously they cannot solve it like we do, like let's put some glue here, obviously they need real more solutions, but basically the same problems that I felt that we had here, simply the same problems that they face over there. That was one of the things that I think I learned.
What did all of you learn? Yes.
Well, yeah, the structure most of it, because like Miguel said that out there you have to like make sure that the things you bought to build something is gonna work and you're not gonna have problems, because that makes like the company maybe have lost some money if you choose a material wrong, and you can not just be fooled.
It was very, because we bought the stepper motors, and the problem was that
They didn't have
the engranes,
The gears?
the gears weren't exact for the motor, and the motor didn't move, and it was a problem. So we had to change the motor to change the gears, and we started like all those problems.
Okay, cool.
For me, I guess it was more about the concepts of motors. Like as you said in the beginning, like a lot of us haven't seen anything of motors and stuff. So like with this, we could see how motors are used in real world. I mean, not just the concept of what it is and how they work, but how you have to like put them here and how they actually are working here. So I guess that was what I learned basically.
That's what you got. Okay, so those were good challenges, and that was a very good experience. So I'm glad. Software-wise, what did you discover? What did you learn? What did you?
Well, in software, we got really frustrated when we did the circle, because we started looking for equations to start using to find a position like every point and stuff, but I don't know, got really frustrating because we did program it and it didn't do what we wanted to do.
Okay.
It was a little bit stressful, but at the end with the letters, when it started to work, like was like a hard relief. Like, well, we managed to do it.
Well, software, so first, the PLDs, I designed them and they work perfectly. But when I started like joining them all together and they didn't start working, was like, what the hell? I mean, they work good, what's happening? And then I started debugging the program, and that took a lot of time. And when I saw what was the problem, was like, okay. So what I did was like, I wasted the time here because it didn't work in the end.
Okay.
But also the circle was like looking for the permanent equation for it. It was very difficult also in programming it. Taking care of the calibration to try to do it more perfectly way was also very hard.
Okay, so it was a good challenge.
Yes.
It was something that's a good challenge. Now, did you discover that you could take, I believe that if you break problems up, or else you could have a very big problem, but you can always reduce it to a very simple problem that is the same. So for example, it's the same for you if you draw a circle, than if you actually draw a squiggly line. In terms of complexity, it's exactly the same. But if you attack the circle problem, it's a little bit easier. And then when you solve the circle, it makes it very easy to attack more complicated problems.
That's what I was looking for, the Bezier equation, because the Bezier takes a lot of curves, different type of curves, and you just have to modify the polynomial expression.
Okay, so Bezier is a very good one. Okay, B-splines is another good one, so you started to research that. And then obviously the parametric representation of curves. That's pretty cool. Okay, so overall, do you think you learned anything in this course or not? Yeah? Now, did the kinematic equations we saw at the beginning of the class help in this way or not? Do you think they would have? Okay. What about path planning? If we went back with what you've learned and what you've experienced and what you've struggled with, if you actually went back and studied, let's say went back to the book or went back to robotics 2 or whatever, do you think you'd see the whole course and the whole equations with a different view, different eyes, or no? Or else, right now you've gained some experience through struggling. And my belief is that's the only way you and I are going to learn is if we struggle. Okay? Do you think if you went back and looked at the book, the Niku book or the Craig book or one of the books that we're studying, and you actually saw them, studied it again, you went through the course again, imagine that you went through the course again, do you think your eyes and experience would make a difference or no? Your new experience would make a difference or no?
Well, yeah, because we started to implement that theory into something like kind of more physical.
Okay.
See, like with the links robot, we have to calculate the angles and the positions of the new, but that's more easier to see the theory like that, like in a project than see it like in papers. Yeah.
Okay.
For me, it's more like, since we already saw the basics, let's put it that way, taking again the course for me will be like, I cannot work with basics, I cannot work from a different level and see how kinematics can, for example, the kinematic equation can take to the next level, not with 6 degrees of freedom, but maybe 12 degrees of freedom, something like that, make it more challenging.
Okay.
Since we already know like the background, we're already working.
Okay, so you've got good basics,
I guess that's the best way to learn. I mean, if you get hands-on something and then you experience like you struggle with something and then you go back, at least you have an idea of what are you going to struggle with. So you start looking for that and not like just looking at concepts just flying around, you know? So yeah, it's if we go back, if we do this first at the beginning, it's easier, at least for me, to understand stuff than just doing it. I mean, to learning and then doing this, it's easier to do this and then
learning. Okay. So do you think, are any of you intending to go to graduate school? Yes?
or masters.
Yeah, master's or PhD. Are you thinking about doing that? Are any of you thinking about continuing this type of work, designing and building mechanisms and robots and stuff like that? Do you think you'll be doing that? You'd like to do that? Okay, so do you think you're going to be the meanest engineers out there or no? Are you confident you're going to be the best engineers out there or no? Yeah, I don't, it doesn't sound too convincing. Are you? Yeah or no? Okay, well I agree with you. I think you're going to be the best engineers out there. I think you are. And I'm very proud of what you're doing. So that's pretty cool. So I'll edit that out if you want. But let me get your robot, how about we get it to run again?
Yes.
And now at close.
Ay, bonito.
Sorry. Since there's like a lot of friction, the gears.
Okay.
That's it.
Cool. So I'm going to take a couple of snapshots. And what do you use the joystick for?
We have the manual control, but I can load the program if you want.
It would be cool just to watch it, yeah? Just to watch what you did.
Yeah, we first start out controlling the Gantry robot with the joystick just to start moving and see.
Just to see if it moves. I mean,
And the structure was good and
we perfect.
Is that an analog? I guess it's an analog joystick, is
Yes.
it?
Yeah.
Okay.
We have to move it to the original position.
That's fine, that's fine.
And that's it.
Uh-huh.
like that.
That's pretty cool. It has very good response.
Yes.
It's a very good response.
That's why I
Congratulations.
was looking for a PID, because if the joystick is giving me good response, I was like, the PID should work very good.
Yeah, the motor should do. Do you think after this course, do you think you're going to continue and try to work on that PID and
Yes.
fit that? Okay. Yeah, I strongly suggest you do. And today we're talking a little bit about the parametric equation, something you could do. So you can do a simple control if you go slowly, but follow the path. So do a parametric equation and then sample your curve. You should be able to do it. And then it would be very interesting once you put your PID control.
This is actually, I mean, for me, I'm taking like several topics in control and automation, and well, PIDs is like.
Okay, so you're going to
everything.
use the same test bed, you're going to keep it on?
Yes.
That's a good idea. Yeah, that would be good. And when you do it, I'd be very honored if you share it.
Oh, that's it.
If you share it. Yeah. Well, congratulations to all of you. I think you did a fabulous